Yeah, in this video, I'm going to talk about relativity again. Relativity, you could take some science like Isaac Newton's theory, Aristotle's theory, and take it for granted they're going to give you a good explanation. I don't understand why relativity is so confusing. A lot of people will tell you it's confusing. Listen to some of those other videos about relativity. That people talk about relativity, and they're going to say it's mind-bending or mind-boggling or whatever it is. Anyways, in this video, we're going to talk about a few of those hurdles we have in relativity. If you are traveling close to the speed of light, there would be no more space in the universe for you to travel through, because the universe, according to Einstein, is the speed of light. A bubble, which the universe exists inside, which gives everything a limitation of the speed of light. Now, the speed of light is made out of protons. And a proton has zero mass. So, for you to even travel the speed of light, you would have to have a ship made of protons, because you have mass. There's too many contradictions in Albert Einstein's theory of relativity. He wrote his books, Special Relativity, SRT, and General Relativity, GRT, without the idea that he received his rewards, let's say, for papers. He wrote 5 papers. And but they have nothing to do with relativity. They have to do with certain aspects of experiments in science that are part of the scientific community. And those were his opinions. But special relativity and general relativity are not part of that, those papers. Those are Pacific papers. The other part is 10 years later, after he wrote General Relativity, he found out the universe was expanding, which means that if you have a ship made of protons or light, you have to have it has to be a ship made of light. In Hubble's world, you turn you're traveling at the speed of almost the speed of light, and you turn the flashlight will continue to travel. It still has room to travel. But the universe is so big that the assumptions of relativity are imaginary. They're only imaginary ideas. And in fact, an imaginary idea is a fairy tale. His idea of flat space and the galaxies, the stars, the planets making impressions in the fabric, it means we live on the horizon. We live on the top of whatever the universe is made of. And if we're living on top of something, we're not inside of it. We're living outside those perimeters. Let's say a ball. We walk on top of the ball. We're not walking in it. And that's Einstein's universe. We're walking in it, but in reality, we are outside of it, because that's our surface. That's our ground surface. That's the surface of space. But like I said, we're so small. In the Hubble universe, we are outside that bubble. Now, Einstein's ideas are based mainly on the speed of light, and he has taken factual, scientific controversy. I don't know about controversy, but what we believe to be scientific fact, and he has redone it. He has reinvented those to fit for his light project, which is the speed of light. Like I said, you'd have to have a ship made of the speed of light. The only way we can reach the speed of light, being that we are made of mass, is slowly but surely. We have to gradually reach that velocity. And there are deterrents in those in doing that, as well as traveling at the speed of light, traveling through space. But nothing is made of a single element. There's so many elements inside, and so many different types of atoms that make up mass or matter, that the idea that matter is a proton made up of proton particles, which, because they're proton particles, have a certain frequency, is mind-bending. I mean, we have to make a ship made of protons to travel at the speed of light. And this is what our science has turned into. We have to bend space to travel back and forth, the past and the future. The past is the past. There's no going back. If the Earth is expanding, it could be the reason why the arrow of time always points towards the other side of the present, which is the future. Because proton particles go backwards and forward, alpha and omega are made up of alpha and beta particles. Alpha forward, beta backwards doesn't mean we can travel through time. That's what their elements are. That's what light is its elements velocity is, let's say. So what it's made of. That's what those particles do. I made an assumption that The speed of light is only the speed of light if we use a second as our clock. Everything ticks per second. But there are clocks that tick faster than seconds. So how does light fit in if it never changes? It doesn't fit in. You could do something in half a second relative to everything taking a second or more time to do. But if you do that and do it in half a second, then you're going half the velocity. Or you're going twice the velocity in half the time because you're doing it in half a second. And relativity doesn't take this type of time into consideration. I'm not saying it's a debunked theory, even though there's only 5 people knew in the world what Einstein was talking about when he wrote his books on, actually probably special relativity. I don't know about general relativity. Special relativity, he uses imagination, so it's a fantasy. General relativity took some of those ideas and placed them in the factual foundation of science. And you can't do that because you can't take one proton and say everything exists within that proton. It doesn't. You just can't do it. But in 100 years ago, you probably could. So that's the way that works. I looked at. He had no credentials of his background when he came to the United States because he I guess worked with the people that were scientists that were creating the atom bomb, or in the controversy of that, to where he came to the United States to inform on what Germany was doing at the time. And we made an atom bomb to equalize our forces against war at those times. But that has nothing to do with the speed of light or protons, except for E equals mc squared. There's a lot of energy in small masses, but it's a different type of energy. It's a different density or tension of energy. It's as you go smaller and smaller, the energies become so compact that they're packing a lot of energy. They're not, and relativity taking that energy and putting it on something on the surface elements, let's say, and saying that because of this, the elements can be manipulated and changed, and they can't, because those elements are which make up matter, and matter is a type of particle energy. And there's different types of energy. There's different types of gases. There's different types of weights and measurements. There's a lot of controversy about relativity. If you get into relativity, you're going to get kind of mixed up. But our generation, were born in the aspects of the science of relativity. Our parents knew at that time, because he became a household name. Now, 1925, unless you stayed in the controversy, Edwin Hubble didn't have that type of reputation. And that's why you don't probably hear much about the Hubble universe relative to relativity. Everything is relative. I don't think it is. But you can't change something somebody else already believes. That's like saying that you have to believe in a religion, and people don't do that no more. They don't actually put their whole life in religion anymore. It's more in a economical working type of society. And it depends where you put your spare time, what your hobbies are, what you do when you're not doing your job, whatever you do for work. The era and the times of these inventions in physics were a different age, and we can't go back. Just because a photon has a beta wave that travels backwards doesn't mean that we can travel backwards. The other aspect of the idea is that photons are made of little particles. Now, if you intensify the beam, then they become more closer together. They become more dense. But you take a regular, what we consider to be a flashlight or something, those are just particles jumping around and reflecting light on everything around them. And it allows us to see what's around us. Photons don't run in the human brain or the eyes. Without light, we can't see. It's dark. A flashlight gives that reflection to where we can see what's in our surrounding area. Same as day and night. But they're made up of little darn particles. Now, you can take one of those particles and say that it is equal to something that's going to have to travel at the speed of light, even though it never stops traveling at the speed of light. And as well, it's an imaginary particle, because when you turn off the flashlight, which is the source, it turns off. It goes away. And it doesn't travel the speed of light, and unless you intensify that light to its maximum capacity, which would be the speed of light. But to say that you turn on a flashlight and that light travels at the speed of light, or 186,000 miles a second, it doesn't. It's a whole bunch of different particles jumping around. That's what light is. Light doesn't bend. It doesn't do anything. It goes around corners because it's reflecting off particles that are being generated from, let's say, your flashlight, that seep around corners. But it's more dimmer around corners because it's not a direct direction in that area. It's behind the corner. So light doesn't bend. It like spreads out. But it's more dimmer because there's less light over there, because the light that's coming from your flashlight can't get around that solid corner. And it doesn't travel through things. It travels on top of things. unless you're in the universe in space. Of course, space is a vacuum and it doesn't have a ground. It's three-dimensional. If it had a ground, then Einstein's idea would be right, but it doesn't. If it had a ground, the planets and stars would be on that ground because they represent mass and it's having weight. And that weight in space, in a three-dimensional space, is only conformed to momentum or motion, which makes it turn corners. That's why when we measure something, it's usually going in an orbit around something, like the sun. The sun's attraction towards that particular planet and similar masses means they're both positive, let's say magnets, so one cannot actually take the other one and bring it to its surface because they repel. Same magnetic poles repel. One would have to be positive, one would have to be negative. We're made up in a positive world and not a negative world. It's complicated. Relativity is complicated. But how can you take all these aspects and say that light is the dominant force? Even though it's not a force, it's a light. It's a particle. It can be broken down as a single particle. It's negative in its mass, and it travels at let's say the speed. I think possibly they maybe travel faster. Their density might be more than what it's out to be. Scientists make these observations and do these mathematics, but mathematics don't always mean that that's the exact explanation of whatever they're measuring. You know, I mean, how deep is the ocean? Well, we have a light beam that touches the top and goes to the bottom. But how do you know that that's the bottom? Or where the bottom is if you haven't been there? And how do you know that the instrument not only goes to just a certain depth? So you can say what you want, but in reality, there's no specific mathematics or measurement tool that we can actually go in and measure these particles at. They're too small, and there's too many, and there's billions and billions of atoms that make up small things. Anyways, I put this into motion, this video, about what I think about relativity. I did a lot of research on relativity. Why? Because, like I said, I was born in the time when Albert Einstein had public notice. He became a household name, Albert Einstein. Name's very important. Names are what the Romans said that they could banish people from ever existing by getting rid of everything that's connected to them by their name. And if they did that, they would never have existed. That's their that's what they do when they get mad. But anyways, my background is I've done a lot of research I know a lot about relativity because I always had the idea that if it's a vacuum, how could we be limited to the speed of light if space is what we perceive to be as infinite, never ending? It would be never ending if we're so small that trying to reach the outside of the universe would be ridiculous to even think about. Kind of like relativity, it's to think about the structure of relativity relative to science is kind of on that voyage to being out of sight, out of mind, what makes the planets round? Not a flat universe. Everything would be flat. And he didn't take that perception of a flat space to mean that it was a dimension. I don't think dimensions were a word then, back 100 years ago. Dimensions came later. Probably not too far ahead, but the dimensions in the universe. So, anyways, this is my just a thought of mine video. My name is Rod Kowicki. Thank you very much. Should buy my book. Thank you.